Morning to all. I am G. Indra, Assistant Professor in Physics, Government College of Engineering, Tanjavur. In this lecture, I am going to present you about the topic optics from Unit 3, Engineering Physics, PH3151. Optics is the branch of physics which deals with the behavior and properties of light. Optics studies the interaction of light photon with matter. Also, the topic optics deals with the construction of the optical instruments, which means the instrument that will use light as well as that will detect light are known as optical instruments. For example, telescope, binocular, cameras, microscope, etc. Reflection and refraction are the fundamental phenomenon in optics. First, let us see reflection. We are all familiar with the term reflection. In our everyday life, we used to see mirror, we will see our reflection. In a shiny day, when you look at the water surface, you will find some reflection. So what is reflection? The term reflection refers to the bouncing back of light when light strikes a surface. The reflection occurs when light rays encounter a boundary between two medium. These two medium is having a different optical density. For example, if light is travel from air medium to water medium, that will strike an interface. Interface that will separate the interface is the surface that will separate these two medium. When light from air medium strike the top surface of water, that is the interface, that is getting reflected. Reflected means bouncing back of light from the top surface of water. Similarly, from light from the air medium that strikes a polished glass surface, it is getting reflected. So reflection occur by a smooth and shiny metal surface from mirror, from the soap bubble surface. So reflection, we will see the reflection. So reflection simply refers to the bouncing back of light when light strikes an interface between two medium. This figure will illustrate the phenomenon of reflection. The incident ray that strikes the mirror surface, that is getting reflected. The incident ray, this is the incident ray and the reflected ray. To characterize these two rays, we have to draw a normal to the mirror surface. Normal means the perpendicular to the mirror surface. So these two rays characterized by the angle of incidence and the angle of reflection. The angle of incidence is the angle suspended between the incident ray and the normal. Likewise, the angle of reflection is the angle suspended between the normal and the reflected ray. So, in the phenomenon of reflection, these are all the physical parameters to be noted. One is angle of incidence, which means the angle between the incident ray and the normal, and another one is the angle of reflection, which means the angle between the normal and the reflected ray. The law of reflection says that the angle of incidence will be equal to the angle of reflection. In the process of reflection, the angle of incidence I is equal to the angle of reflection. Next, refraction. Refraction is the phenomenon of bending of a light when light passes from one medium to another medium and due to the change in the speed of light. Look at this picture. So the image of a pencil that we see in the air will be oriented in different, like when we see the part of the pencil inside the water. So this is the best example of the process of refraction. So the refraction is the bending of light during the refraction. um, the change in the speed of light will occur. So light is passing from one medium to another medium. The speed of light will be different for different medium. When light pass from air medium to water medium, or light travel from air medium to glass medium, which means from one medium to another medium, that will the its speed is getting changed accordingly. The path of the light is getting deviated. So this we usually call as refraction. So the optical density of the medium is related to the quantity refractive index. So refractive index is a property of a medium. Refractive index indicates how much the speed of light is reduced in that medium when compared to the speed of light in vacuum. This diagram illustrates the phenomenon of refraction. So the ray that is from the medium 1 is entering to the medium 2. The path of the ray is getting deviated. So the ray that in medium 1 is the incident ray. The incident ray is characterized by the angle of incidence. So uh, to represent the angle of incidence, a normal is drawn at the interface. Interface is the surface that will separate the medium 1 and medium 2. So the angle between the incident ray and the normal is known as the angle of incidence. The refracted ray is the part of the ray that is transmitted to the medium 2. The angle suspended between the normal and the refracted ray is known as the angle of refraction. So the phenomenon of refraction will be characterized by the two parameters, angle of incidence theta I and the angle of refraction theta. Next, Snell's law, which is also known as law of refraction. Snell's law governs the relationship between the angle of incidence and the angle of refraction when the phenomenon of refraction takes place. Snell's law describes how light bends or changes its direction at the interface between two different media with the different refractive indices. Snell's law states that the ratio of the sine of angle of incidence to the angle of refraction is equal to the ratio of velocities of light in the two different media, that is sine theta I divided by sine theta r. Theta I refers to angle of incidence and theta r refers to angle of refraction. Sine theta I divided by sine theta r equal to v1 by v2. v1 is the velocity of light in medium 1 and v2 is the velocity of light in medium 2. Mathematically, Snell's law is represented by n1 sine theta I is equal to n2 sine theta r. Here n1 is the refractive index of medium 1 and n2 is the refractive index of medium 2. By rearranging this, we will get sine theta I divided by sine theta r is equal to n2 by n1, which means the ratio of sine theta I to the sine theta r will give the uh, relative refractive index of the medium 2 with respect to the medium 1. So generally the refractive index of medium relative to the another medium, usually the medium 1 is taken as vacuum. Mu is equal to sine I by sine r. Next topic is total internal reflection. When you look at the bending of light, when refraction takes place, the path of light is getting deviated. So bending will occur, bending of light will occur when light is getting refracted. This is due to the change in the speed of light from one medium to another medium. If the light ray passes from a less denser medium to a denser medium, example from air medium to water medium, it bends towards the normal. So conversely, if it passes from a denser medium to a lower medium, example, from water medium to air medium, the light ray bends away from the normal. By understanding this phenomenon, the process of total internal reflection can be achieved. So what is total internal reflection? So the total internal reflection is a phenomenon that occurs when light ray traveling through a medium encounters a boundary with another medium of lower refractive index. If the angle of incidence of a light ray is greater than a particular angle that is popularly known as critical angle, all of the light is reflected back to the original medium and none of it is transmitted into the second medium. So this phenomenon is known as the total internal reflection. Next, critical angle. In order to understand the process of total internal reflection, we must learn about critical angle. The critical angle is defined as the angle of incidence at which the refracted angle becomes 90 degree. That is, the refracted ray that travels along the boundary direction. If the angle of incidence exceeds the critical angle, the light is unable to bend and refract into the second medium. As a result, it leads to the total internal reflection. Look at this picture. The ray that is denoted in black color that strikes the interface which suspends the angle theta c into the normal. So this is the critical angle. This ray, black color ray, incident on the interface at the critical angle. The refracted ray is denoted in the black color. So that is traveling along the boundary direction. So the ray that is incident on the interface above this critical angle that is reflected back into the same medium. So this phenomenon is most commonly observed at the interface between a denser medium and a less denser medium. So here the medium N1 is the refractive index of the medium 1 and N2 is the refractive index of the medium 2. Usually the refractive index of medium 1 will be greater than the refractive index of the medium 2. So this is denser medium and N2, the medium 2 is the less denser medium. So this phenomenon is most commonly observed at the interface between a denser medium such as glass or water to the less denser medium such as air. When light travels from a denser medium to a less denser medium, the light generally bends away from the normal. When we increase the angle of incidence, the angle of refraction is also increases. At a particular angle of incidence, the refracted ray that travel along the direction of the boundary. So that particular angle of incidence is the critical angle in which the angle of refraction should be 90 degree. If the angle of incidence exceeds this critical angle, the light is entirely reflected back to the denser medium. So this phenomenon is known as the total internal reflection. Application of total internal reflection. The phenomenon of total internal reflection finds effective application in the field of fiber optic communication system. Fiber optic communication is a mode of communication system in which the information is carried as a light wave and it is transmitted through a optical fiber. The optical fiber will act as a guiding medium to the light wave. The optical fiber is a thin strands of highly transparent material which this material is usually a glass or a plastic. The center part of the optical fiber is a transparent material with a high refractive index, which is known as core, and which is surrounded by a cladding whose refractive index is relatively smaller than that of the core. Since the refractive index of the core is large, when light signal meets the core cladding interface at an angle greater than the critical angle, then it is being reflected inside the core itself. In such a way, the light signal sent from one end of the fiber is transmitted to the another end by the process of total internal reflection. Therefore, within the core, the light is propagated by the principle of total internal reflection. Thank you, students.